Welcome to Flipped Classroom. Our topic is programming basics, and for this video we are looking at comments and variables in Python. Our learning intention is we are learning about writing comments and using variables. And our success criteria is I am successful when I can comment my code, create and use variables, and understand the different types of variables. So comments are used in lots of programming languages, and it is a way for programmers to write in their native language information about the code that they're doing. Comments can be added to the program by the programmer for helping either the programmer themselves remember what the code does, or helping their team communicate what the code is meant to do or is currently doing. And the code is a very useful tool for trying to debug the program. It can also be used so the programmer can add details and copyright information about code that they're putting onto the internet for people to use. Revision information is also put into the comments to show what changes have happened and what work has happened over the time of the life of this program. Now, adding comments in Python is quite simple. All you have to do is make sure that there is a hash symbol at the start of your comment. Now, your comment can be at the start of a line, or it can be after you've done some code. And you can also use comment as a debug tool to comment out code that used to be there to see how the program changes, or if you're trying to update the code to do something slightly different. Let's switch over to PyCharm now, and we can put in some comments into our code. So here we have our code in PyCharm. We're still using the Introduction to Py course. Up the top here, we have a comment already pre-written, and that's a comment at the top of the file saying that this is a comment for the comments file. In the next line, we've got the function print, and it's printing out the string hello. And we've put a comment after this saying this is a comment on the second line. And notice how we've got the hash symbol at the start here to state that it's a comment. So it'll run this code here, and then it'll skip that comment. Now, this is not a comment because it's inside a string, and you can tell that on this version of PyCharm because of the color change. And finally, we need to add our own comment to the bottom of this file. So I'm going to add in here. So I've just written, here's another comment. Now let's check if our code runs. So I'm going to press the run button, and it shows us the hello. We were expecting that because we had that command in there. And then we've got this is not a comment because, again, as I said, this is a string, even though it's got the hash symbol. The hash symbol is inside the string, so the compiler treats it as a character, not as a command in the system. And then we've got the hash symbol, which says that anything after it is a comment, and there's my comment, and you notice it's not printed out. We'll hit the check so that we can check if our code is correct, and it's given us congratulations, and we can move on to the next section. Let's switch back to our notes now. Now let's start looking at variables. In general, variables are a section of memory that is set up by the program to store some information that is to be used in the program. So variables have a type. Now these types could be strings, numbers, booleans, or any combination of these types of things, and we'll talk about that a bit later. And you can manipulate these variables. So you can either project them onto the screen by printing them, or you could add and subtract or multiply those values. And you can also test the variables. So that's checking if the right thing has been typed in by the user, or it might be comparing a bunch of numbers to work out whether or not you've got a profit or a loss. To define a variable in Python, it's quite simple. So in Python, all we have to do is assign the variable, and it is defined. So I could assign x equals 3, and now that has stored the value of 3 into x, and that is a number. I could then assign x equals Fred, and that stores the string Fred into the variable x. Now the thing with Python is we don't have to change anything. We could have these on different lines in our code, and there will be no errors. It will automatically just assign Fred into the x, even though we've previously assigned a number. In Python, you can do something called chain assigning. Now, this is a really useful trick where if you need to assign the same number to multiple variables, you can do that all in one line. We need to name variables, that way we know what they're being used for. Variables don't have to be a single letter like I have used on the previous parts of this video. We can use names and words. However, there are some rules about naming variables. Now, a variable name must start with a letter or an underscore. It can't start with a number, and it can only contain alphanumeric characters and underscores. And variables are also case sensitive in Python. This means that the variable lowercase a is different to the uppercase A variable. Now let's switch over to Python and have a look at assigning some variables and seeing what happens. So here we have our program again. We have our variable definition we're going to have a look at, and you can see the chain assignment up the top here, A equals B equals 2. And you can see that we've got a comment here just so that we know what it means. We need to print something. So what we're going to do is we're going to go print. We've got this A equals as a string, and then we've added on another string of whatever was in the box A. And we do the same for B. Now I'll talk about these functions a little bit later. Next, we're setting the string greetings as that greeting. Then we're going to print that off. And then we're going to reassign greetings again. But this time it's asked us to put in a different value. So I'm going to just type in hello as my value. And then I'm going to print that off. So let's run this. So I'm going to hit the run button again. And it's come down here. So you can see the second line here, which says print, has printed out A equals 2 because we set the value of A up here to be 2. It's done the same for B. It's then written greetings, and there's that. And then on this 8th line, it's gone greetings equals whatever the string of this greeting was, and we changed it to hello, and you can see that there. We'll hit check to see if this works fine, and it says it does, so we can move on to our next part of this program. Now let's look at what happens if you don't define the variable. So you can see in this first line, I've defined the variable as 1. And now I'm going to print something else, and we need to type something in there because at the moment it's got a space in there. So let's delete out that word other variable and type something in there. And it comes up with this red line, and that's the good part about programming in an IDE is it tells us if there's going to be an error. However, if you're programming this in Notepad and then running it in a compiler, it won't show that error until it runs. So let's just run that program, and you can see here that an error has come up. Now for this program, we were expecting that error because the name something has not been defined. So I've put in that word something, and it says it doesn't exist. Now let's check our code. It says that it's fine because that's what we were testing for this. Let's move back to our notes and we can move on with types of variables. Let's look at variable types. In Python, we have what's called the primitive types. Most programming languages have what's called primitive types. They are the basic types that are used in that programming language. For Python, we have 4 primitive types. We have integers, which are positive and negative whole numbers. We have floats, which are decimal numbers. We have strings, which can contain no characters or any characters. Now, strings are surrounded by either a single quote or a double quote. And finally, we have a Boolean. Boolean are true or false values, and these can be represented as ones or zeros. So let's go back to Python and have a look at how to program some of this. So in Python, we have a function called type, and that tells us what the type is for a specific variable. This line here, line number 4, is saying, get the variable number, tell me what type it is, and then print it out on the screen. The code is asking us to change, it says here, determine the type of variable for float number. Now, the name gives it away, but we want to use similar code. So I'm going to type in there type, and then I'm going to type float number. This will tell us what type of variable float number is. And when we run the program, It tells us that the first number is of type int or class int, and the second number here is of class float. Let's check our code, and it says it's all correct, and we can move on. So let's go back to our notes and look at type conversion. So let's look at converting types. Now we know Python has the 4 basic types, and you can actually change between the types so that you can manipulate those variables. We have a bunch of functions that will help us convert those variables. So we have int, which will convert the variable x into an integer. So I could just write int, open bracket, my variable, close bracket, and it outputs an integer. I can do the same with float, which converts it to a floating point number or a decimal number. And I can do the same with str, which converts it to a string. Now this can be useful for a bunch of different reasons. It could be useful as adding a number to a string. So let's say I get the user to input something and it's a string. I can then pull out that number and convert it into an integer or a float and then add it to my variable. Or I could do the reverse. I could do a bunch of calculations and then I want to print that out. And I've got that example at the bottom there. So let's switch over to Python and have a look at how this works. So here we have our program. So our first line there has a variable called number, and it has the number 9. And from previously, we know that when we use the function type, it tells us what type of number it is, and we should expect an integer because it is a whole number. The next variable we have is float number, and it's got 9.0, and it will print out that number 9.0. But next line, we need to type in some code. It's already got the print there for us, but it wants us to convert the floating number into an integer. And we can use that function int that we talked about before. So I'm going to type that in. So I've typed in my int function, and I'm using the variable float number. So what this is going to do is going to get the variable float number, convert it to an integer, and then print that out. Let's run the program and see how this works. So the first one told us exactly what we expected, told us it was an integer. The second one printed out the float number, which was the 9.0, and that last one converted it to an integer. And you can see it's just got the number 9 there. It doesn't have that 0.0 because it's no longer a decimal number or a floating point number. Let's check our code to see that's what we wanted, and it's gone correct. So we know that we've got it right. Let's go back to our notes and have a look at some arithmetic operations. Computer programs are there to manipulate data, and so what we need to do is to be able to do some maths or arithmetic operations on those numbers. So we can manipulate our variables using our basic operations. That's our plus, minus, times, and divide. Make sure we get the right symbols for times and divides because a forward slash and a backslash mean two different things. Now in Python we have a bunch of other operations. So these operations are stuff like power, which is to the power of, modulus, which is the remainder of a number. So if I divide a number by another number, what's the remainder? And floor is a divide that then gets rid of anything that's left over. So if I do something like 17 floor 8, it'll tell me that the answer is 2. It ignores any decimal part of that number. So let's go have a look at some arithmetic operations now. We have our floating point number in line 1. It's setting up a variable called number and it's setting it to that 9.0, and that makes it a floating point number. Now we want a new variable called result, and that result is dividing this number by the number 2. Now if we remember back, division was that forward slash, so I can just type in there number divided by 2. And that's all I've got to do. For line 5, we have a variable called remainder, and in there we want to put the remainder of that division. Now we can use the modulus operator, or as it's sometimes called the modulo operator, to calculate this. So here I am, I'm going to delete that out and I'm going to type in number because that's my variable that I'm working with. I'm going to put the percentage sign in, and then I'm going to put in the number 2. So that's going to work out the remainder of that. The next two lines are just going to print out those two variables, and we're using those type conversions to convert those numbers into strings so that we can print them out. So we run this to see if it works, and we get our results. So the result equals 4.5. We knew that half of 9.0 is 4.5, and the remainder is 1.0. because when we do the modulus of this, it comes out as that. Now, because this number here is a float, it converts our answer also into a float. That's why it's 1.0. If we wanted it to be a whole number using an integer, we'd have to typecast that as an integer. Now let's check our answers to see if it's right. And it's come up with correct, so we'll be able to move on. Let's go back to our notes and have a look at some arithmetic shortcuts. So let's say we have a variable that we want to do something to and then put it back into the original variable. Instead of writing the whole line, there are some shortcuts that we can use in Python. Now, to do this, what we do is we append an equals operator to the end of the operation that we want to do. Here are some examples. If I do x plus equals 3, that's the same as if I typed x equals x plus 3. So we're taking the variable x, we're adding the number 3 to it, and then we're putting it back into the variable x. We can do this with some of the more complicated operators as well. So if I do x asterisk 5, that's x to the power of 5. So what that does is it goes x to the power of 5 and then put that back into the variable for x. Let's try that in PyCharm now and see how it works. So here we have our functions again. Again, we're setting up that variable number to be 9, and we're going to print it out to make sure it is set correctly. And we're going to go number minus equals 2. So we should see it take away the number 2. Next, we want to change this so that it adds the number 5 to the previous value. So to do this, we're going to use this plus equals operator. So let's go plus equals. And remember what that's doing. It's getting the variable number, adding 5 to it, and then putting it back into that number. So we should see the number go down and then back up. Let's test that. And we can see we started off with the number 9. We took 2 away, which makes the number 7. And then we added 5, which makes the number 12. Now let's press the check button to see how this works. And we've got it correct. We can go back and we could change these numbers and see what actually happens with different numbers there, or even different operators. Let's go back and look at some Boolean operations and comparisons. The last little bit of this video is about comparison operations. And comparison operations are used to compare two different variables. We can compare the variables, and when the test comes back, it will tell us one of two things. It will tell us whether it's true or whether it is false. A couple of tests we can do in Python are equality, and that's that double equals sign. We can do also greater than, less than or equal to, and greater than or equal to. And we can also check if two variables are not equal. So let's go into PyCharm and see how this is done. So I have my two variables here. I have the variable 2 and I have the variable 3. And I want to check if variable 2 and variable 3 are equal to each other. So I'm going to use that equality operator. So I'm going to put in those double equal signs. And just remember, it is a double equal sign. It is different to a single equal sign to check if they're true. So when we run this, it prints out the answer false. And that's what the program is aiming to do, because the number 2 does not equal to number 3. It is storing in the variable here is equal whether or not the variable 2 and the variable 3 are equal. And we can check this against its expected answer, and it comes back with correct. And again, we could play around and change these numbers and see what happens with our answers here. Let's move on to doing some more complex comparisons. Here we have some more variables, and we're going to be looking at a couple of extra parts. So we have variable 1, 2, and 3, and we've put in the values 1, 2, and 3 respectively. Now this is a chained operation. So it is comparing the variable 1 and seeing if that is smaller than the variable 2, and it's checking if the variable 2 is smaller than the variable 3. Now, when that runs, it should come out as true because we know that 1 is smaller than 2 and 2 is smaller than 3. Now, the task we need to do here is to check whether the variable 3 is strictly greater than the value of the variable 2. So we've got our assignment here is greater, and we'll put in the greater than sign there. So this is going to check variable 3, is it greater than variable 2? and then it's going to print that out. Let's run this to see if it works, and we get 2 trues because we know that that's true and we know that's true. Again, we can play around with these numbers and rerun it and see what happens. Let's just press the check, and we've got that correct. So we can move on to our next lesson. As always, like the video and subscribe so that you can get more learning from these topics.